everyone. This is a Legacy School Science lesson for Chemistry Chapter 11 on preparing common salts. For this lesson, you will need your Science Checkpoint Book 3, pages 153 to 158. Some people have difficulty thinking about the word salt. All they can think about is sodium chloride, which is common salt. There are many different salts, and some of them have a wide range of uses. Calcium chloride is a salt that forms white crystals. It is used to absorb moisture from the air and is known as a drying agent. It is also used in food processing, in medicine, and in speeding up the setting of concrete. Zinc sulfate also forms white crystals. It is used in making cosmetics, some deodorant, the textile material, rayon, and glue, and in the bleaching of paper. It is also used as a herbicide and in the treatment of sewage. And it is used by chemists in investigations of substances to find their chemical component. In this chapter, we are going to look at two methods of preparing salt, using metals and acids, and using metal carbonate and acids. The chemical reactions that take place in these two methods of preparations are represented by these general word equation. Acid plus metal will give us salt plus hydrogen. Acid plus metal carbonate will give us salt plus carbon dioxide plus water. Acids and their salt. The three acids that can be used to make salts are hydrochloric acid, sulfuric acid, and nitric acid. The salt produced by these are chlorides, sulfates, and nitrates respectively. So if the acid used is hydrochloric acid, then the salt will be the name of the metal plus chloride. If the acid used is sulfuric acid, then it will be the name of the metal plus sulfate, and if it's nitric acid, it will be the name of the metal plus nitrate. For example, sodium chloride, sodium sulfate, and sodium nitrate. Here we have some examples of chloride, sulfate, and nitrate salts. You see they have different colors and different textures and so on. We have copper nitrate, copper sulfate, sodium chloride, iron chloride, and nickel sulfate. Preparing a salt from a metal and an acid. The example we're going to use is zinc. So we're going to prepare zinc chloride. Granulated zinc is added to hydrochloric acid in a flask, figure 11.3. Bubbles of gas rise from the metal, pass through the liquid, and escape into the air. Eventually, the bubbles are no longer produced and some metal remain in the flask. The content of the flask are poured into a filter paper in a filter funnel. The zinc metal remains behind and the liquid passes through and falls into a beaker. The liquid is poured into an evaporating dish and heated gently until some solids appear. The mixture is then left to cool and more evaporation take place. After this, the mixture is filtered again. So these are the steps we use in making the salt. First, we take the zinc and we add it into the hydrochloric acid. We're going to start seeing the bubbles, which are the hydrogen gas. After the bubbles have stopped, that means the reaction has stopped. It's no longer continuing. We will have some zinc granules that did not react. Then we're going to take this mixture and filter it. Place it on a filter paper on top of a funnel, and we're going to filter out the liquid. The liquid is then placed on a evaporating dish. It's heated until some solid starts to appear, and then it's left to cool and continue to evaporate, and the salt form will be zinc chloride. Preparing salt from a metal carbonate and an acid. The example we're going to use is calcium chloride. So the carbonate used in this reaction is calcium carbonate in the form of marble chips. Some marble chips are added to hydrochloric acid in a flask, bubbles are produced, and the chip dissolve. Some more chips are added and more bubbles are produced, and then the reaction stops, and some of the chips are left in the solution. The content of the flask are poured into a filter paper in a filter funnel, and the solution and chips are separated. The liquid is poured into an evaporating dish and heated until some solids appear. The mixture is then left to cool and more evaporation takes place. When the mixture has been left to cool, it is filtered again. So, The second reaction, it's the same steps as the first. Instead of using just a metal, here we are using a metal carbonate. And this metal that we're using in this example is calcium carbonate in the form of marble chips. So the marble chips are placed into the acid, and the acid, we place it a little by little because they're big. So we wait until they are completely dissolved and no more marbles are there, and then we keep adding until no more reaction. We know the reaction has stopped by the stopping of the bubbles. If there is no more bubbles forming, that means there is no longer reaction happening. Then the solution is filtered, placed on a filtering paper. Then it's placed on an evaporating dish, left to cool. Same steps as making the salt from acid and a metal. The only difference is that here we need to filter twice. So after it's cooling, after it's left on the evaporating dish to cool, it is filtered again. The gas that was produced in the first reaction was hydrogen gas. The gas that's produced in the second reaction is carbon dioxide. Salimuzzaman Siddiqui and the chemicals from natural product. The activities involved in preparing salts are used on a daily basis by chemists all over the world. Some of this work is directed at extracting chemicals from plants for use in medicines and insecticides. One of the pioneers in this work was Salimuzzaman Siddiqui, 1897 to 1994, who was born in Subha in India and then went on to work in Pakistan. Salimuzzaman Siddiqui attended school in Lucknow and had many interests including literature, music and calligraphy. He went on to University of Algera, where he graduated in philosophy and the Persian language. He moved to London to study medicine, but after a year he moved to Frankfurt in Germany to study chemistry. While there, he continued his interest in arts and literature. He held the first international exhibition of his painting in the city and translated the work of German poets into Urdu, which is still popular today. Siddiqui returned to India and, guided by Hakim Ajmal Khan, he set up a research institute. A plant known as snake root or sarpaganda has been used for thousands of years in India to treat ailments, and Siddiqui began work on extracting chemicals from its root. In 1931, he extracted from these roots a substance that cures abnormal beating of the heart. He named it Ajmalin in honor of Hakim Ajmal Khan, who helped him on his return to India. Siddiqui went on to discover more chemicals from the plant's root, and many are still used today to treat heart disease and mental disorders. In 1942, he used a range of solvents, including ether and dilute acid, to extract chemicals from the neem tree or heel oil. These chemicals can be used to kill bacteria, viruses, fungi, parasitic worm, and as natural insecticides. He continued with his work, discovering over 50 substances, and went on to discover more in research projects with other scientists and their students. In 1951, Siddiqui was asked to set up research programs in Pakistan, and in 1953, he founded the Pakistan Academy of Science and the Pakistan Council of Scientific and Industrial Research. In 1967, he set up the Postgraduate Institute of Chemistry at the University of Karachi, which in 1976 was renamed the Hussein Ibrahim Jamal Research Institute of Chemistry. Institutes and academies are places where scientists can gather together to discuss their work, and Siddiqui built up their work in chemistry and natural products to international importance. In 1983, he helped to set up and became a founder member of the Third World Academy of Science. At the age of 93, he retired from running the institute and carried on research in his laboratory. This is the end of this session. I hope to see you again soon.